I think we can start. People may trickle in a little bit more, but we have all the main interested parties. Yeah, so we can start with a couple of updates. Yeah, so the focus is we discussed with Ansgar before the call, and we wanted to maybe focus a little bit more towards getting ready for Amsterdam, like some of these changes that we've worked on and like discussed. Maybe see how we can kind of use this call and this working group to organize ourselves a little bit more so that we have a little bit lead time and we make sure that these changes are ready for Amsterdam. So we can start with a couple of updates, and then Ansgar also can lead a more in-depth discussion on this point. Yeah, so maybe if Marcin wanted to start, he wanted to give an updates on PerfNet. Yeah, I think he gave a very nice presentation at the research call previously, but a lot has happened since then, including the interop progress. So yeah, I'm excited about this.
Hi, do you hear me?
Yes, yes.
Okay, a few words about our findings in PerfNet project. As probably no one is surprised, Modex is our bottleneck in the whole Ethereum. Right now we have the worst client performing at only 11 megagas per second. What we can say here, like if we want to push gas limit to 60 million before Fusaka, then all clients, especially Aragon and GEF, would need to improve significantly performance. Otherwise, we can do it. And on Fusaka, we will reprice the Modex, and the target is to go for 100 million gas limit. We need to perform at least 53 megagas per second, and even after repricing, Aragon and GEF are not there yet. So we have two options, or actually three. One is to improve performance in clients if it is possible. Second is to increase Modex pricing even more, and we can do both as well. But achieving this level of 33 megagas per second is not enough, as Modex will still be a bottleneck. So we need to reprice it wisely and think a few steps ahead. And I would like to present some analysis of next steps and next bottlenecks. So if we exclude Modex, then our bottlenecks looks like this. So even without Modex, we are not at the 100 million gas limit requirement yet. Three clients out of 5 are, but Nethermind and Bezu need to improve a bit. For Bezu to achieve 33 megagas per second, there is a need to optimize ECAT and EC recover. And for Nethermind, we need to improve ECMOL. There are no other blockers between 100 and 120 million. So after doing this small optimizations, which should be possible because of other clients are performing better in this compiles, we should be able to move. Of course, if we only take into consideration the computing, like not state, etc. So focusing only on computing, we should be able to go to even 120. But what are the bottlenecks then? As we said, for Bezu and Nethermind is ECAT, EC recover, and ECMOL. For other clients, GEF, REF, and Aragon, if you look at worst cases, easy recover, easy add, and easy move. So we have bottlenecks on the protocol level, not only client specific. Let's take a look on them one by one. So the fastest clients on ECAT are Gef and Erigon performing at 58 megagas per second. Bezu needs to improve significantly. And for Nethermind and Ref, it seems reasonable to point it in having like 50 megagas per second performance. It doesn't seem like impossible to improve it. Esimul is faster than ECAT, so Erigon is outperforming other clients by a lot, and it should be quite easy for everyone to achieve at least 50. Easy pairing, Nethermind and Ref need to improve, but generally it looks fast and doesn't even need repricing. Based on this data, maybe we don't have, maybe we need better test cases, but basing on this, what we have, it doesn't need repricing. And easy recover, it's the biggest bottleneck except Modex. So the best client is performing at 58, and it will be probably challenging for every client to go to at least 50, but might be possible. So as a summary, after Fusaka, if we reprice Modex to not be the bottleneck anymore, then we should be able to go to 120 megagas, and it's reasonable it's probably able to go even to 150 megagas per limit without repricing more things. And for sure, we will not go further than 170 because it's like the fastest clients are performing at this level. So we probably need to answer some questions at this point. Maybe the level of 120 or 150 megagas limit is enough, or we need to go further. I don't know. Are computations a bottleneck at this level, or there are other limitations? Probably it will be stayed at this point. Do we really need more gas limit? And are APEs like multidimensional gas metering, which is a brilliant idea and will be presented later today, is it coming to the Ethereum? If it is, then it will change the way how we think about gas limiting blocks. So probably further analysis doesn't have sense. But if we are talking about Modex repricing and looking for the best way to do it, then we need to consider other steps. So what will happen if we will reprice ECAD, ECMUL, and EC pairing and EC recover? What is the next bottleneck? So next, it looks like we can target even at 200 million gas limit. Free clients are ready for it, and let's take a look at them. So Gef is ready for 200, and for 250 needs to optimize only Blake precompile. Erigon is also ready for 200, and for 250 needs to optimize Blake, Ketzak, and some client-specific opcodes. In Ref, it's only Blake precompile, and in Bezu, it's Blake, Ketzak, and some opcodes. And I'm not 100% sure that we are testing Bezu correct way. We added warm-up, but I think that this numbers would be a bit higher for Bezu, so I'm not sure that it is accurate. So let's take a look one by one at this new bottlenecks. So Blake all clients should be able to achieve 66 megagas per second. Ketzak is even faster. So we should be able to achieve 200 million gas limit for repricing, maybe even 220, and for sure not more than 265 because fastest clients are performing at this level, and even 250 will be extremely challenging. So one last step in the future. What if we reprice also Blake and Ketzak? Then Ref and Nethermind is already on the moon. GAF is starting to the moon, ready for 300 million gas limit. And we need to take a closer look at Polygon and Bezu. But first, GAF, so only already ready for 300 million, only 2 opcodes to be optimized for 400 million, and 4 more to 500 million. Seems like 500 million is achievable. In Aragon, 2 opcodes to be optimized for 250 million and a few more for 300. And in Bezu, there are like 10 opcodes to be optimized for 250 and 6 more for 300. But again, I'm not sure if we are testing Bezu correctly. Maybe warm-up is still not good enough. So coming back to Modex, because this is my main focus in this presentation. Right now, it's performing at 11 megagas per second. So 36 million feels safe, but even 45 isn't comfortable. Before Fusaka, if Aragon and GAF will optimize, then we can go for 60 million. If not, we can do nothing. In Fusaka, we reprice Modex. And after Fusaka, 120 million will be achieved with only small improvements in Bezu and Nethermind. And potentially 150 seems realistically achievable without other repricings. Potential next steps would be to reprice EC Recover, EC Add, and EC Mol. If we will potentially do it in Amsterdam, we will be able to go to 200 million and maybe 220. And as a last step, if we reprice Blake and Ketzak, then some clients are ready for 500, and 250 to 300 remains realistic because there are like probably too many blockers at this in this area to go further. So we want to reprice Modex, and after Fusaka, the next bottleneck except Modex will be performing at 40 to 50 megas per second up to 58. So we shouldn't expect Modex to perform slower. Like, we don't want it to be a bottleneck after Fusaka. So it's absolutely minimal requirement for us to reprice Modex to perform at 55 megagas per second. If we want to not have Modex as a bottleneck after next repricings, potential next repricing, then we need to aim in range 66 to 73. So probably we want Modex at 75 plus. And if we consider Blake and Ketzak repricing, then we need to aim in 100 megagas and more. So it looks like that on this graph. 100 million is not realistic with current shape of AIP 783 because like no one is achieving the speed. 75 megagas per second looks achievable, but it will require improving in Aragon and GAF being 3 times faster, which probably will be extremely challenging or impossible. And even the level of 55 is far away. So why current pricing is like that in AIP 783? So it's focused mostly on addressing edge case scenarios. 3 out of 4 changes made to Modex pricing are affecting only 0.3% of historical Modex calls, but addressing like worst case scenarios. Fourth change is bumping mean price from 200 to 500 and has wider effect, but all the changes are affecting about 38% of Modex calls, according to Tony's report, which is linked here. I will paste it on the chat later. And we even already know affected addresses. So impact of this API in current shape is relatively small, while pushing performance bottleneck much. It's pushing from 11 to 26, so a few times. But there are no more edge cases to cover. What we can do now, if we want to have Modex performing faster, is to add general cost increase, but then it will affect 100% of usages instead of just 38. So what we can do, potential change, is like at the very end of Modex pricing equation, result is divided by 3. So we can achieve significant cost increase by changing the variable from 3 to 2, or by not dividing it at all. So in variant 1, if we divide by 2 instead of 3, the cost will be higher by 50%. We will move worst case from 26 to about 39 megagas per second. 100% of Modex calls would be affected, and performance still wouldn't be fast enough, so not a good option. In variant 2, we will not divide the result at the end at all, so price will be tripled. Current worst case will be moved from 26 to about 78. 100% of Modex calls would be affected. Yes, and price will be increased by 200%, so tripled. After such increase, we could potentially revert the previous changes, but probably not worth it. As it will require additional testing, and it's covering only worst cases without any impact or common reward use cases. So in my opinion, if we want to modify this API, we just need to add one more change and don't touch the previous ones. Yeah, so at the end, we need to answer the question: do we want to make Modex significantly faster for our clients, but for the cost of affecting 100% of users and calls and tripling the price? Or maybe we want to make changes as small as possible. So currently only 38% of calls are affected, but it will require hard optimizations from Aragon, Graph, and probably Bezu. So if you want to be at the level of 75 megagas per second, so ready for 200 million gas limit and more, there are two options. We can triple the price, and then Graph and Aragon will be there, or they need to triple the performance, which will be extremely challenging. So that's the open question at the end, what we want to do. So in my opinion, let's try to optimize Modex in Graph and Aragon. And in the meantime, I will prepare a PR draft to triple Modex pricing, and we will need to decide what to do next. Are there any questions?
Yeah, Ken?
Yeah, I have a few questions. Is Modex bad for a particular range of input sizes, or is it just across the board?
Can you repeat?
Is Modex bad for a particular range of input sizes?
It was, but the worst cases, like edge cases, are already addressed. And right now, it's we can consider like the common cases which are on network as the worst cases or close to worst cases. So like there is nothing to optimize. We can only change general pricing of it.
I was saying that for the is it bad for like 256 bits input, or is it bad for all of the ranges? Like if you was to reprice it?
From what we have, it's performing similar for all valid ranges. It's already like narrowed down a lot because if let's say base and modulo is in common cases, it's almost always 32 bytes, and that's our current worst cases. If it's smaller than 32 bytes, we are pricing it as 32 bytes. So there is no way to explore it by using small base and modulo. And if it's higher than 32 bytes, then we are doubling this part of equations. Like price is doubled. So it's also not anymore a worst case. And for exponent above 256 bits, price is doubled. And at exactly 32 bytes base and modulo and 256 exponent, we have edge case for that. And I would need to check, but it's probably one of the worst cases.
Okay, I see. And if you was to reprice ModX free X, do you know how many contracts would be affected? Like, is it used a lot?
Yeah, it will affect every ModX call. So a lot of them, all the contracts would be affected. Like it is why in the initial, like in the current shape of this API, we did it this way to affect as small actors as possible. But seems like just this increase seems not be enough. And if we want to go further, then there is like no more edge cases to cover. And if we change the general pricing, then everyone is affected.
Okay, I see. Yeah, I had two other questions, but I don't want to hog the time. Well, I see no one else has their hands up. For the EC add Marlin pairings, is this because most clients are using a very old library? I think it's the Matter Labs library from like 6 or something years ago.
Seems there is no answer, but maybe plausible. Oh, Bezu is not using that one, Luis saying.
So
Yeah.
actually, I think Geth and Eragon, like they are using some old close player library. I have like done some benchmarks, like if we would replace the implementation with Knark crypto, and like it gives like approximately 3-4 times faster easy pairing and easy mul. So I can share the spreadsheet for that.
I think Geth uses Gnak right now, or at least they recently switched to it. I think.
So for PLS 12381, but not for PNG54, I think.
Okay.
Okay, yeah. Cool.
Kev, it seems that if there is any other question, maybe you can ask in the group. It seems like a kind of important discussion. And yeah, we can move to Jacek, who also has an update on the repricing EIP. Oh, Ansgar has something to say. Yeah.
Yeah, just a very quick comment. I'll put it in chat. I just wanted to make sure that people are aware in general. We should keep in mind that basically the way we approach these pricing or these basic benchmarking pricing considerations before Glamsterdam and after Glamsterdam will be very, very different. So before Glamsterdam, we're kind of in this world now where all the different opcodes and precompiles are differently fast on per gas basically on all the clients. And so basically we just now always constantly chase the next bottleneck and remove the next bottleneck and the next bottleneck and try to reprice and whatnot. And there's always one specific bottleneck. And then in Amsterdam, the idea at least is, and we can talk about it a bit later in the section properly, but the idea would be that we basically make it so that all of the compute operations cost the same per kind of time that they take. at least at the fork, and then of course over time then things will diverge again. But basically that means that after that fork, we will no longer be in the mode of like tackling the next specific bottleneck, because all of them will kind of be equally good or equally bad. So then it will be much more a loop of figuring out where we can push more, where we can basically make things faster so that we can make them cheaper again afterwards. So I just wanted to, as a general kind of comment of like, we should realize that what we're doing right now, this kind of effort is more like a until Amsterdam kind of process. That's all.
Yeah, makes sense. And then maybe after Jacek, we can like discuss more on this approach and like what's the priority for Amsterdam. Yeah.
Okay, guys, can you see my screen? I hope you can.
Yeah.
What Marcin showed was the scenario if we increase a gas limit, with especially with the focus on keeping precompiles safe in terms they compute enough, the computation is enough to increase the gas limit. Now, as a reminder, this EIP comes from a slightly different angle and basically says, what if rather than increasing a gas limit, we lower computational cost of certain opcodes? This EIP specifically focus on opcodes plus some precompiles. And we're not touching mod X because Marcin EIP is much better in replacing mod X, but we do touch in this EIP, let me just scroll down, an easy pairing. The main problem with lowering cost of easy pairing as per this schema here was exactly the performance of Geth and Eragon. But as Ivo has mentioned before, there is a GNARC library right here, which is provided here. We measured it and confirmed this is about 4 to even 5 times faster in the worst cases than the existing library used by Geth and Eragon. So that removes the bottleneck of lowering cost of easy pairing. Again, in this schema, when we lower cost of most of the opcodes. As Ansgar mentioned before, this EIP aims to rebalance the computational cost across everything. So the same unit of computation will cost the same gas in theory, because in practice, clients differ between each other. On Marcin page slides, you could already see the difference between the clients. Unfortunately, I didn't have time to prepare my take on this. It's not different from Marcin, but as soon as I prepare it, I will post it to the group. But in the meantime, I can show you some another interesting slides, what we did on the new precompiles, so BLS 12. And for the BSL 12, we have 7 new precompiles, which we measured using the same method. And let me just jump straight to the conclusions. And we, according to our measurement, the gas proposed in the EIP is surprisingly accurate, and all our measurements actually confirm that, with one exception that we might want to lower mapping for G2, but it's a minor thing. Now, having said so, I need to go a little bit deeper into details, because there's an interesting case of MS multiplication, G1 and G2 multiplication, which let me just show you this here. So the red line is the nominal gas cost, what we want to charge. The blue lines is the actual measured gas cost. So as you can see for EVM1, this matches almost exactly as if the gas cost schema or schedule was made for EVM1. If we jumped around, if we go to Besu, for example, we see some variation here, but it's not as much different as you would expect. I didn't mention that the x-axis is the number of pairs that are used for the multiplication in a single core.
Jacek, you've muted yourself, I think.
Oh, sorry. What was the last thing you heard me saying?
Number of pairs, the
Okay.
x-axis.
So a number of pairs on the x-axis, it looks good for the red lines cover the blue lines for the Besu EVM1. And if we scroll to the things where it doesn't look nice, for example, Rev, we can see that what we expect as a gas cost differs quite a lot, especially in a low number of K pairs. It's not a huge problem, but it might be an issue if you've considered some kind of vector attack on the network. So here's another diagram that I want to show you. Bear with me for a moment. And let me explain to you. So the numbers on the y axis shows you how much the actual computation was than gas cost that we charge for that specific precompile. So we can see that in this case for Lev, it's fine. It's almost 1 for anything larger than 32. But for the pairs lower than 32, it might be up to 8 times more costly to execute it. It's not a huge issue in terms of security because those precompiles are expensive anyway, and the possible vector of attack is quite low, if non-existing, really. But interesting to see that there are actually differences between implementations, sometimes quite substantial, as per this case here of Rev. And going back to Ansgar note about having the same gas cost per computational unit, as we see here, clients differ between each other. But in general, we can confirm BLS 12 is safe to be implemented, good to go, and the pricing is actually very accurate. Okay, any questions?
Thanks, Jacek. Maybe we can segue. Is there any direct question?
Kev asked if it's safe even at 100. No, it's safe at the moment. So 45 or whatever is the current limit. Mm-hmm. If we go to 100, I'm afraid it won't be that much safe anymore.
Yeah. Okay. Yeah, I had a question relating to maybe how do people feel about such a change for Amsterdam? Like we haven't done such a big rebalancing of prices before, but maybe we can segue into Ansgar section because I know he wants to talk about this thing as well.
One sec, I have small technical difficulties. If you give me 30 more seconds.
Yep. And then in the meantime, so we are um, uh, taking more time than I was expecting. So there was going to be another presentation from Maria on this new like multidimensional gas metering proposal that we have, which I think is quite interesting for this discussion. But if we probably won't have enough time, so maybe we can go on with the discussion and then we move this presentation to the next time. So we also have enough time to discuss and to address all the questions. But yeah, let's see after Ansgar section terminates. Yeah.
Yeah, good. Maybe there's someone else. I'll put the link to. I just had two slides literally in my presentation. If someone else could maybe share their screen.
Yeah, I can try to present this. Yeah.
Sorry about that.
No worries, no worries.
Perfect. Yeah, if you could full screen. Um, um, yeah. So basically, I'm not sure if maybe it's easier to read if you go slideshow. Um, yeah, perfect. So basically, like the idea is just I wanted to briefly like talk about Amsterdam. It's not super well prepared. Just a few thoughts here, basically. And so basically, just for general context, this is just my best guesstimate in terms of governance process for Ethereum. But like I think we have roughly 2 guaranteed months for ERP proposals for the Glumstone process. There's a good chance that there's still going to be some more time after that, but basically at that point it will already be, oh, this ERP is coming late into the process. Maybe we can't fit it in anymore. These kind of things. Whereas like anything that wants to be properly considered, basically will have to be proposed within the next roughly plus minus two months, I would say. And then that would just be the general kind of EIP, and then there would definitely be more time than that for finalizing any parameters that come with an EIP. But just to give us like a general idea of the timelines here, so I think it's already like urgent enough that we should start to really have a concrete plan of like what are the features we want to see in Amsterdam here from the pricing side, because there's not that much time. Um, and so I just wanted to briefly like run through the different categories here. So the first one basically just is like kind of what Jessica already was talking about just now in terms of compute, but basically the general category of I think we really want to ideally, not all of that has to be in Amsterdam, but ideally we really want to get to a place where for all of the three major resource types, that is compute, that is state access, and that is data, we really homogenize all different types of operations that touch that specific resource so that they all cost the same per amount of effort that they cost, right? So that means for compute, it's just the amount of time. And that should be basically like the per second cost should always be the same in terms of gas, no matter what kind of compute you use. Um, and for compute, we are the farthest along. I think we have a good chance of like JASX EIP basically and being ready and being agreed for Amsterdam. I am a bit worried that as of today, we are not necessarily in a place that we will have the same true about the other two. Um, which is just unfortunate because as we need to like this is a little bit like already the next point, but as we need to basically reprice these different dimensions relative to each other, basically if we have a dimension like state where basically things are still very much mispriced, the different ways you can basically cause stress in terms of loads and reads and writes and whatnot. That just means that we basically have to make everything much more expensive so that we can basically create more headroom for scaling. Whereas if we homogenize everything first, then we basically only have to reprice to the extent necessary. So basically, like one point I want to make is that as of today, we are not yet on a track where we will have state repricing ready because no one is yet working on it deeply for Amsterdam. So if we think we would want to have a first batch of changes for state ready as well, we would really need to very soon start to think hard about like what even are we tracking here? What are the different things we were trying to benchmark? Obviously, state is just more complex because it's not as pure as compute. But just wanted to flag this. Maybe at the end we can have a quick discussion about like how we think about this. But yeah, I really am worried right that as of right now we're not necessarily on track to change anything in Amsterdam there. Um, then. The third one obviously is data. Data is in a way less problematic. It's a bit simpler. You don't actually have to do any benchmarking. Also, Davide, there's some switching back and forth between the presentation and emails. I don't know. Anyway, in terms of data, it's really just about like making sure that in principle we don't have any big oversights. Yeah, in terms of what contributes to to basically like the worst case size of a block. Yeah, and then the question is just, am I overlooking anything by even categorizing it in compute state and data? These are usually the three that come up the most, but there's of course also like memory and kind of related questions. So like if there's anything else kind of urgent that we also want to track, then yeah, that we also need to pay attention to. And then this is another major one. Um, we probably also really want to like make a change in Amsterdam that changes the relative pricing. So basically like also not only look at like that all the different ways to access state are priced according to how much actual time they take, for example, but also specifically um um, want to make sure that like how much headroom do we have for example, for data or for state compute versus for compute, and basically that a block that only uses compute has the same kind of worst case load as a block that only uses a lot of state or access a lot of data. The big problem there is that with compute we can probably kind of make these changes without many big backwards compatibility questions because most of that is just making things cheaper. Um, as we start really changing the ratio between resources, though, we will not get around having to just make big changes to pricing that will potentially impact existing contracts. And so I think we pretty urgently, if any of this is supposed to be in Amsterdam, then we really urgently need to start having a strategy for like how we even think about backwards compatibility and like how to even analyze mainnet for contracts that could potentially break as things become more expensive, this kind of thing. Obviously, like a lot of these are kind of weird edge cases because in principle you're not supposed to hard code gas limits for subcodes and whatnot, but of course that sometimes in some cases happens. So we really need to have a strategy for this. Um, and also, why is this even so urgent for Amsterdam? Well, because in Amsterdam specifically with these two headline features that are in discussion right now, ePBS/delayed execution and block level access lists, the relative amount of available resources for all of these three categories will change quite a bit. And if you briefly want to go to the other slide, Davide, um, just I was just trying. I'm not sure how correct this is. This is just a sketch of like trying to map out like how do these two features potentially change like affect all of these dimensions, just so you get a feeling for like why does the relative availability of these kind of change maybe. And so like if you look at ePBS, right? So basically there's two things. You will have a longer window for propagation of the payload, which just means you can have more data. Yeah, right. So basically you could um, well, either make all data cheaper or we just basically now have more time, more way to basically raise the gas limit before data becomes a problem again. Um, and then on execute, but ePBS also gives you more room for execution. But interestingly enough, now it's a different window. Like today, basically, like it kind of doesn't matter. You can split your time equally between downloading and or executing. You have to be ready by 4 seconds into the slot, right, for attestations. But with ePBS, you would have a different deadline, or delayed execution, you would have a different deadline for just having received and verified that you have the payload and having fully executed it. So that means that now you have like this specific extra headroom just for execution that you could not otherwise use for data. So that's basically some a way in which compute basically now could explicitly be cheaper than data because you have more time for that, right? Um, and so and not only compute, but also because you have more time for execution, it also means more state access. So in a way, data should now, in relative terms, become more expensive because there's a tighter constraint on data than there is on execution relative to what we have before. But all of these dimensions, we have more room now in absolute terms. And then block level access list is even more messy in a sense because it has many different kind of ways in which it impacts performance. I'm again not even sure that this is quite conclusive or like even the right way of approaching it. But the way I think about it is like there's these two different sides of block level access lists. There's at least in the current proposal, there's the read locations, just the locations, not the values. What that allows you is you can basically just at the very start of the block already start loading all the values that will be accessed during the block execution. Um, two nice things. One, you basically you can start loading them all at the very beginning. You don't have to wait until they are actually hit, and you can load them in parallel, which gives you extra performance versus sequentially. So overall, just means you will be able to have more state reads specifically, but right, not writes, just reads. So that specific only gives you more reads. And then with the other proposed part of block level access list is the state diff. So basically, like you typed out again. Noise. Yeah, sorry for conquering your device here. The other big one is basically like the write locations and the values, and that basically impacts gives us the ability to parallelize transaction execution, so it gives us more compute, and it also impacts state this time because it actually like lets you start computing the post block state root at the very top of the block already, which also allows you, in principle, gives us more time, more ability to allow for more writes, make writes cheaper. The one way in which actually like block access make things worse though is that the basically now has this extra sidecar to the block, which now couples state and data in a way. So meaning that like every state access now also increases the data size of a block because that value has then to be written into the access list by the miner afterwards, by the block producer. And that actually means that is a counteracting force. So basically, like all of these will give us more state access. This actually now gives us less state access again, and we would have to actually like benchmark exactly like where that net comes out on. Basically, just again giving you the intuition that basically like any repricings that we want to do, and that are not just like that this none of this affects ESX work, right? Like the just making sure that all the different types of compute are homogenized in their price, that is valid either way. But like if we think about how expensive should compute in general be compared to state access, like this basically we have to make sure that we base it on the actual version of Ethereum that will be live in Amsterdam. So I just want to give you like a feeling for how complex all of this is, but also how if we do not make any relative repricing at all in Amsterdam, then we actually are in a pretty bad place because then we actually created a lot of extra headroom for some specific type of consumption, but we can't actually make use of it because now we will be blocked by some bottlenecks of exactly the types of resources that we could not make cheaper. So and especially like the state side of this is actually quite messy because it's affected in all these different ways. So basically, just if we can go back to the other slide. So basically, just wanted to highlight that like it's a pretty complex topic, and I just think that we kind of, at least in terms of like the kinds of general proposals for Amsterdam, we probably need to have them out in two, maybe I don't know, maybe there's a bit more headroom there, but like kind of in the next few months. And I feel like right now the main one that we will get is the state reprice, the compute repricing. But I think on all of these other fronts, ideally we should at least some of those we should also kind of get ready for Amsterdam. And yeah, just wanted to highlight basically that problem. Just to briefly mention other potential pricing features, that's really much more optional in case that's possible. One idea would just to make actually sure that like data and blobs count against the same kind of cap of data. Of course, blobs should have a discount factor because you only need to sample them. You don't have to fully download them, but basically the idea could be that they actually get to move basically like the call data into this blob gas limit. And then the other one is this multidimensional metering proposal that I'm not sure we will have time to actually talk about today. But basically, that's also a really interesting new proposal by Maria and Davide. And actually, like the multidimensional metering would also allow us to have more general targeted caps. So already in Fusaka, we will have the total size cap on a block, but size is really the only thing you can cap today because size is something you can statically analyze. Everything else is a runtime value. So in order to have a cap on a runtime, like the total amount of, I don't know, catch-ups in the block or whatever, if we wanted to have such a cap somewhere, that actually requires as a prerequisite multidimensional metering because you first have to track that specific operation separately from everything else before you can cap it. So only if you were to decide to ship the multidimensional metering in Amsterdam would more types of caps even be a potential option. And then the last thing I think Sophia also mentioned it in chat earlier was the idea of potentially already having ZK EVM aware pricing in Amsterdam as well. So again, all of this just and ideally, if we have a few minutes to discuss this briefly, like I'd be really curious of people's takes. Like, where do you agree in terms of urgency of things we should ideally try to get into Amsterdam, and is there maybe some activity that I'm not yet aware of, or like how could we try to like coordinate on making progress on this pre-Amsterdam? Yeah, that's kind of all from my side.
Yeah, we have 8 minutes, so I think um, yeah, maybe to your second point. Yeah, I'm also curious, like whether there is any work that we started already that any team started on like benchmarking for state, not just for compute.
Yeah, so actually, in principle, I think my understanding is that Guillaume's team is ramping up to start doing that kind of work exactly. I don't think they have so far been focused on like results that would immediately inform Amsterdam decisions. But they're definitely a team to go talk to at least about this. Um, I'm not actually sure what Guillaume's team is called. Something something. It's the team that basically previously also worked on Berkel and statelessness and so on. Ah, yeah, stateless team. Makes sense.
Mm. Yeah, Francis.
Yeah, quick question about like benchmarking state. Every client, maybe not every client, like, a lot of clients use different databases, etc., and have very different access patterns. Like, how does this work of like benchmarking state?
Yeah, so this is why state is in general just harder. We kind of need to think harder about what it even means to benchmark. In principle, you can just benchmark per client, right? It will just be that the results will just be much more different across clients because they make different choices. So it doesn't always mean that because on state, like on compute, whenever you have a client that's vastly slower than another client on a specific operation, that's usually an indication that that client should increase their performance. On state, it can just be that like a client is just slower on a certain type of access pattern because that just falls out of their different implementation choice, and we might just not be able to do anything about it. But we still need to just track it. So I think we can still like the types of situations you benchmark would still be the same across all clients, right? Um, it's just that the results will then look much more different. Or
Yeah.
did you have a different, or do you think it even like yeah, are there other complications you see?
Not other complications. It's just that kind of like it's really hard because everybody is like so different in these situations, like unlike compute and stuff. So yeah, just curious like how like we're thinking about it. Um, the second thing I want to kind of like maybe touch a little bit because you mentioned like about the priorities and stuff. Um, I feel like it would be really great if we can, like, because we're already doing this like homogeneous like a pricing thing, it would be really great to make things like really, really configurable so that potentially it can be adapted and L2s can price things differently based on their kind of like different situations and stuff. And just try to mention it and see if that will become a priority and if there's anything that we can potentially help like push that forward.
Yeah, that's a very good point. I think with a lot of these changes in general, like we are now only now starting to get into the habit of thinking, how does this relate to L2s? That's also why I put, for example, L2 extensibility for specifically this data pricing, the data metering change, because that would hopefully be something we can make easily extensible for L2s to use because they have been asking for a way to separate out call data pricing from everything else for a long time now, of course. But yeah, there's also other questions of like exactly make pricing more modular in general so that it's easier for L2s to actually just deviate from L1 pricing in general. That's something that I think is a really, really good long-term goal. And then the question is, can we already make this first batch of changes be implemented in a way that allows for that, or is that something that basically will take more time to find a strategy for?
Yeah, and maybe one comment here. I think like we had discussed a bit of this, potentially having a standard config for this pricing parameters at interop with Francis. We also talked to Marius from Geth. I think his intuition was like a little bit pushing back, saying that like at the moment, like all these parameters are in the compiled code, and then if you take them out into like some config, it would slow things down significantly. But it was just his intuition. Like we don't have like any like analysis or like any like measurement of like how much slower it would actually be. So I think it would be like something interesting to explore potentially as well.
Okay, so it seems like the kind of like the thing that might need like investigating is like trying to do a POC maybe on Rest and guessing like some of the clients and see how hard it is to make it configurable and either any like performance impacts, etc. Does that sound right?
Yeah, that's my understanding. Ansgar, or what do you think? Or
Wait,
other?
so say again.
Oh no, just trying to say that it seems like the current blocker or unknown for making things configurable is mainly about, okay, we should probably like try to POC it in some of the clients EVM implementations and see if it makes things really hard for hard forks or like changing EVM or whatever, or and if it makes a little bit difference on the performance side. So if there's no issues,
Right.
it seems like we can do it potentially
I
alongside
mean,
with this.
I'd
Yeah.
be curious. We have a lot of client devs on the call, whether people have general comments on the feasibility of making pricing either fully modular. I'm not sure if that's even a coherent thing to say, because I think pricing is not just a table of values. There's also this logic that like some operations have like some specific kind of pricing logic. So I'm not sure how exactly you would make that fully modular, but basically like at least making it more modular. Like how feasible do people think that is, or how easy would it be? Or maybe it's the kind of thing that we just have to basically just like try as a pilot project, basically to actually see. I could imagine that that's the kind of the part of the code that just many people don't have a strong opinion on because it hasn't been touched that much in the past.
Yeah, yeah. And yeah, to respond to Francis, I think that would be a really nice POC to have. Like, and to Ansgar point, I mean, the functions, like those functions have parameters, right? Like what we take out is the parameters themselves, right? Like in the simplest implementation, basically. Um, um, you don't, the function we can commit to them, we don't need to modularize them, right? But yeah.
I mean, it depends. Like, for example, L2s also need the way to like handle data a little bit differently to begin with, right? So ideally, modular pricing there would give them that flexibility as well.
Okay, okay. All right, so I think we need to wrap up. But yeah, we are overflowing with Maria's presentation on the multidimensional gas meeting. So I'll try to set the next call a bit like earlier, maybe the week after next, since I think next there is the research call at the same time. Yeah, so we can continue the discussion there, and I'll try to see if we can make progress on like the with the stateless team, if maybe invite them if
Yeah.
this there. Yeah.
And I think we will also like from the kind of the L1 scaling kind of track at DF, we'll keep working on this quite a bit in the next few weeks. So if anyone from outside the F that also is basically wants to collaborate on these topics outside of just the compute homogenization, because that one I think is already the most kind of specific. So any of the other topics there, specifically state or something, if you want to collaborate on that, do reach out to Marius or Tim or me, or Davide, specifically on pricing. I think that really makes a lot of sense. And then, but also do go and read Maria's and Davide's work on the multidimensional metering. That's actually really nice work, if I may say so.
Thanks, Ansgar. Yeah, we'll link it. Yeah, Maria sent it. We'll also send it to the group, and then we can start with that one next time. Yeah, and thanks everyone.